this video, we're going to talk about solving radical equations. So a radical equation is an equation that contains a radical or a square root in it. And let's start with this example. Let's start with 7 times the square root of x minus 2x minus 3 equals 0. We want to solve this equation, which means we need to get the x by itself. But the problem is we have one x under the radical and one x that's not. And so the first step in this type of problem is to isolate the radical. So these two terms, negative 2x and negative 3, I want to get rid of them. So I'm going to add them to both sides to get rid of them on the left-hand side. Plus 2x plus 3. And so I have 7 times the square root of x equals 2x plus 3. Now, I could go ahead and divide both sides here by 7, but if I did that, I would have 2/7 x plus 3/7, and then I would have to eventually use the distributive property with these fractions, which would be quite cumbersome. So I'm not going to divide by 7. Since this is all one term, since it's multiplied, I'm just going to go ahead and square both sides. And when I square both sides, the radical is going to go away. So remember, when you square both sides of this right side, you have to distribute. You can't just do 4x squared plus 9. It doesn't work like that. You have to distribute. So this left side, I get 49 times x because the radical went away. And then I would have this, which needs to be distributed. So 2x plus 3 times another 2x plus 3. Using the FOIL method or using the distributive property, I get 4x squared plus 6x plus 6x, that's plus 12x, and then plus 9. And now I see that I have a quadratic equation here. I have one of these is squared, and then these two are just regular linear terms. So I want to get 0 on one side so I can go ahead and solve by factoring. So I'm going to subtract 49x from here and from here. And I'm going to have 0 on the left-hand side, which is exactly what I wanted, equals 4x squared. And then 12 minus 49 is negative 37x plus 9. All right, so now I can solve by factoring. And this actually requires advanced trinomial factoring, which is in lesson 109. So advanced trinomial factoring is when you look at the first and the last term, you look at the quadratic term, the quadratic coefficient, which is 4, and then you look at the constant, which is 9, and you multiply them together, and you get 36. So I need to think about two numbers that will multiply to 36 and add to this middle term, which is negative 37. And once I figure out what those two numbers are, which is negative 1 and negative 36, I'm going to take the middle term and split it into two separate terms. So I figured it's negative 36x and negative 1x. So you can see this equation I'm looking at now is the same as the equation above it. I just took the middle term and separated it. The reason I did that is because now I can go ahead and factor by grouping, because I can factor out 4x from here and I'll have x minus 9. And then if I look at these two terms, I can factor out a negative 1 and have x minus 9. And then I see that I can factor out x minus 9, and then what I have left over is 4x minus 1. And then remembering how we solve when we factor, we set each separate factor equal to 0. So we set x minus 9 equal to 0, we get x equals positive 9. And if we set 4x minus 1 equal to 0, we would solve and get x equals 1/4. That was 4. It looked like a 9. Okay, 1/4. Now I have my two answers, so I'm happy, and I could say, oh, there we go, these are my answers. But you have to check your answers when it comes to radical equations. So let's go ahead and do that. So checking, I have to check by putting my answers into the original equation. So I have 7 times the square root of x, so 7 times the square root of 9, minus 2x, so 2 times 9, minus 3 equals 0. Putting it into the original equation, I have 7 times 3, which is 21, minus 18 minus 3 equals 0. Hey, that works out. So 9 is actually a valid answer. Sometimes we get extraneous answers that don't work. Then I could check 1/4. So I could say 7 times 1/4 minus 2 times 1/4 minus 3 equals 0. So let's see if that works. Well, 7 times the square root of 1/4, which is 7 times 1/2. 7 times 1/2, which would be 7 halves, minus 2/4 minus 3 equals 0. Is this true? Remember, this is 3 and 1/2 minus 1/2 minus 3 equals 0. Hey, that works too. So actually both of these answers are valid. Oftentimes one of them or both of them are incorrect. In this case, we got lucky and both answers were correct. But that doesn't mean that you don't have to check. You always have to check. All right, so let's do another example. Let's do 8 times the square root of x minus 3x plus 3 equals 0. All right, so this one, and I encourage you to pause the video if you want to try it on your own. Otherwise, you can just go along with me and see what the answer is. But I'm going to do the same thing and move this term by adding it and move that term by subtracting it from both sides of the equation. And so then I have 8 radical x equals 3x minus 3. Now I square both sides. Remember, when I square both sides, I get rid of the radical, but then on the right-hand side, I need to distribute. So I have 64x equals, if I have to distribute that, I have 3x minus 3. You don't have to write this step if you can do it mentally. 3x minus 3. So I get 9x squared minus 18x minus 9. Now, just like before, I want to get 0 on one side, so I can go ahead and factor it. So I'm going to subtract 64x from both sides. And I have to subtract it from that middle term because that's the one that it's a like term with. So I have negative 18 minus 64, which is negative 82. This one also requires advanced trinomial factoring. So if you multiply the first and the last coefficients, 9 and 9, you have 81. So you want to think about two numbers that multiply to 81 and add to negative 82. So this again is an easy one. We know that it's going to be negative 81 and negative 1. So I'm going to rewrite this with the middle term split up. Minus 81x, oh there's an x here, and minus 1x minus 9. You can see that this blue equation is just like this kind of aqua equation above it. It's the same thing, I just split the middle term into 2. Now I can factor. In this first two terms, I can factor out 9x, and then I have x minus 9. And then in the second, oh, this is a plus 9 here, by the way. Oops, there's a plus 9. So in the second two terms, I can factor out a negative 1 and then have x minus 9. And then if I factor out the x minus 9, I'm left with the 9x minus 1 equals 0. So my two answers are x equals 9 and x equals, let's see, 1/9. Now remember, I'm not done. I have to check those. I have to check both of them into the original equation. So in order to do that, I would say 8 times the square root of 9 minus 3 times 9 plus 3 equals 0. Does this work? I have 8 times 3, which is 24, minus 9 times 3, which is 27, plus 3 equals 0. 24 minus 27 is negative 3, plus 3 is 0. So yes, this does work. Let me try the other one and check the other one. So I now have 8 times the square root of 1/9 minus 3 times 1/9 plus 3 equals 0. Does this work? So the square root of 1/9 is 1/3, so I have 8 times 1/3, so that would be 8/3 minus 3 times 1/9 would end up being 1/3 plus 3 equals 0. 8/3 minus 1/3 would be 7/3 plus 3, which is not going to be equal to 0. So this is not true. No. So this is an answer, x equals 9. This is not an answer. This is an extraneous solution. And sometimes you get no answer, and then your answer is the null set. So you would write just null set, or you could write the symbol like this. But in both of these examples, we did get answers, which is fantastic.